Good morning, everybody, and welcome to this week's Machinery Safety Seminar webinar from Pilz. Today we're going to cover safe radar systems, optoelectric sensor technology for greater productivity. I'm your presenter for today. I'm Jamie Thomas, and answering the questions today will be Alex Bryce and Jason Reed. If you wish to ask any questions, there's a box down the side. You can ask them in there. They're anonymous, and Jason and Alex will answer whatever they can. Today we're going to cover what radar and optoelectric sensors are, just a quick overview, application suitability, and then specific functionality and specifications for Lightcurtains, 2D scanners, and Failsafe Radar. And then we'll just go through some of the considerations you have to give for the applications where you're going to use these products. So what are safe radar and optoelectric sensors? They're generally protected devices which do not rely on a physical separation between the person and the hazard. So there's nothing that's actually going to stop you going through. They're covered by a standard 61496, and the latest version is 2020, and that's safety of machine, electrosensitive protective equipment. This was revised previously in 2013, released 2015, and there's two parts to this standard. Part one is just the general requirements and tests. Part two is particular requirements for using active optoelectric protective devices, or you may know them also as AOPDs. And the way they operate is in different forms, but they will all emit a signal, different types, whether that's radar or infrared, and they look for movement or presence of a person or a machine or whatever you're trying to protect against within an area or passing through them. The typical devices, we have pictures down the side, top one being Lightcurtains, most commonly known. Then we have floor scanners, and then Failsafe Radar. They're generally used when people require frequent access into the danger zone. So this could be machine tending, loading, unloading, checking, or even just doing operations within the vicinity of the danger area. And it's where you want to replace a physical guard. So it may be to do with if you have to go in regularly, you don't want to have to go through a gate access system where you're stopping the machine, opening a gate, going in, doing what you've got to do, come back out, close the gate again, restart the machine. So all these things take time. And if you can do that without that extra time of opening and closing, then accumulatively over a long period of time, you will have higher machine availability and more productivity. But it is application specific, and you have to go through some considerations and assessments, which we'll come on to a little bit more later, to make sure that it is suitable for the application. But what they will do is when they detect, they can stop the machine when a person enters the danger area, or trigger some of the specific operations. They can prevent unexpected startup, so you've got occupancy detection as well for some of the devices. And when we talk about trigger machine operations, this could be for specific machines. So for instance, if you talk about presses, they have a single or double brake functionality. So single brake would be if the press is either automatically loaded or automatically unloaded, and you go in to load an item into the press, into the mold, you would break the light curtain, and as you come out and that light curtain remakes, it automatically cycles the press. Double brake would be if it's manually loaded and unloaded. So if you load it, when you then take a workpiece out, that would be classed as the first brake. Then you load a new workpiece in, that's the second brake. and this is counted within the program. And then once that second break has cleared and the light curtain's remade, then the press will cycle again. So you can use some of these devices for trigger operations, but only in specific applications for specific machines. They may also be used for environmentally challenging areas, because you may want to look at them outside. Inside you may have dust, vibration. It might be a case that you've got high or low temperatures. And when you're looking at different devices, you can look at these environmental challenges and see which one's going to be suitable for that. And we'll go through again a little bit more on that later on. So what we're going to do now is look at the different products, functionality and their specifications. We shall start with light curtains. So safety light curtains are most commonly made up of a sender and a receiver. And the sender will transmit an invisible infrared beam, and that will be detected by the receiver. And they're generally used to identify access or entry into hazardous machine areas. If somebody goes into these hazardous areas, they will break the beam, which can immediately trigger a safe shutdown command, or as we said with presses before, another reaction by the machine. They'll be mainly used where you want to remove barriers, and as we said, to increase time or make the ease of entering and exiting, which if it's frequent, more easily. And it's maybe when the process isn't going to be running 100% of the time. So like we're saying, if you need to intervene, you've got to load, unload, you may have to take pallets in or different things into the area, then this is where light curtains can really come into their own. But when you're specifying these products, you've got to take particular care and around your safety related assessments, and also make sure they're suitable, and also that they're positioned in the correct place. So you will do a risk assessment, and then through your concept and assessments, you can make sure that you aren't introducing any new hazards or not satisfying enough with the risk assessment, and also do the stop performance test. This is to make sure that you have the light curtains positioned in such a place that once broken, nobody can then access a hazardous event within the machine. So the machine has had to come to a complete standstill before anybody can get near the hazard. Light curtains, the individual beams have a very high resolution, so they can provide what's called precise edge definition, which basically means that almost immediately that beam is broken, it will react and it will shut the light, and it will then turn off the outputs of the light curtain. Light curtains themselves have very fast reaction times, so they will do a scan, and this is very fast, and that will allow, against other devices of this kind, maybe a bit of a space saving. So this is one of the considerations where you're looking for specification of the products. So as we said, these devices are all covered by the standard 61496, and in 61496 it talks about the type, and they're all categorized by type. The previous version 2013 made a change to the performance level achieved by the type. Previous to the 2013 version, type 2 devices could achieve performance level D, and that meant that they were very often used in robotic applications, because 10218 specifies that you need PLD Cat 3 for all safety related parts of the control system. But back in the 2013 version, released 2015, that was declassified to performance level C. So now you've got to look for type 3, type 4 devices to achieve the requirements for these types of machines. So type 2 devices, we say PLC, type 3 devices if you need PLD, and type 4 devices for PLE. The majority of light curtains will only come in the versions of type 2 or type 4. Just as a bit of a note, if you're interested, at Pilz, we manufactured the first ever Type 3 light curtain, which is out in the marketplace. So if you do need performance LD, you can purchase a light curtain which is suitable for that level of safety and priced in such a way. So Type 2 devices are the cheapest, Type 4 device is the most expensive, and Type 3 obviously somewhere in between. When you're looking at the resolution, so this is the distance between the individual beams of a light curtain. They come in 3 different types. So you have finger detection, which means there's 14 millimeters between each beam, which determines that nothing can pass through the light curtain without being detected. Hand detection light curtains, 30 to 40 mm resolution, depending on which one you get, means again that a hand could pass through, but as soon as you get to the wrist, then the beams will be broken and the light curtain triggered. And body detection light curtains, they don't have a specific resolution. You will find that they are categorized by the number of beams in the overall field of the light curtain. If you're doing this, then it will be determined that the body is the first point detected. So you would have to consider that there's going to be possibly 850 millimeters, which is your normal arm length, which could pass through the light curtain before it is triggered. So when you look at this, we'll come on to the stock performance calculations later, but if you to get closest to the hazard, finger detection light curtains would be the way forward, and the ones that are going to give you the longest safety distance would be body detection. There's also guidance given on shock resistance values within 61496, and there's 2 classes detailed here. Class 3 M4 means they will withstand acceleration values of up to 15 G, and class 3 M7 acceleration values of up to 25 G. So again, just a bit of a note that our PCN Op2 range has a very fast response time of 6 milliseconds, so that sort of goes back to what we were talking about in the previous slide, but also an acceleration value of 50 G. So it's double the 3M7 value, which is quite a useful product feature. So light curtains as well, they have some advanced functions. So they're not just once detected, they turn off. They're capable of being muted or blanking and cascading. But to carry out these functions, you're going to either need an advanced or intelligent light curtain, or you're going to need a programmable controller so you can do some of this functionality within via code within the controller. So muting. Muting is a function which allows the light curtain to be broken, but the machine to continue running. So it's maybe where you want to have, as we've got a picture here, pallets of product maybe going in or coming out of the machine, and you don't want the machine to stop every time, because obviously that wouldn't work. There's 3 types of muting, and this is pictured is cross beam muting. So that's where you have 2 sets of sensors looking diagonally across each other, and as we'll talk about the pallet, in this case the pallet comes in, it will break both of them beams. That will trigger a reaction to say either ignore the fact that the OSSDs have gone out. So if you're doing this with a controller and you're doing it in code, the outputs from the light curtain will turn off. So what you would do then, you would ignore that status and monitor the status of the sensors. If you're doing it with an advanced set of light curtains, like we offer, this is all done within the light curtain. So the OSSDs will stay on, meaning you can use a standard relay for that. But either way, whichever you're doing, it will allow then the light curtain, the product to pass through the light curtain and out the other side, and once the beams are remade, then the light curtain will come active again. There's a couple of points to be aware of here, is that actual cross of the beams should be in the danger zone and not close enough to the back of the light curtain that they can be defeated with somebody putting something underneath the beams, underneath the bottom of the light curtain, and defeating the muting function. The other type of muting would be L-shaped muting. So this is where you would have a series of beams or sequence of beams leading up to the light curtain, and you would require timers for this. So you would trigger maybe beam 1. This would say, okay, now we set a timer. I'm expecting to see beam 2 triggered within a set period of time. Yes, that has been triggered in the right time frame. Then the light curtain is muted, and upon the release of the first beam, then we would again trigger another timer, which is sufficient enough for the pallet to have gone through the light curtain, but nobody to sort of follow it in. And this then, once that time has elapsed, then you can then the light curtain again will become active. And this takes a little bit of setting up to make sure that you're not going to have any period of time where the light curtain is not active and allow unauthorized access through it. So for crossbeam and L-shaped muting, they will only allow traffic one way through the light curtain. If you need to maybe have product going in and out via the same opening, then you want to look at sequential muting. So what this will do is you will have 4 sets of sensors, 2 on the way in and 2 on the way out, and as they're broken, instead of the timers, you'll break the first 2. It's not used a timer, the light curtain is muted, and then as the pallet in this case has passed through the light curtain and the next sensors are triggered, then you can reactivate the light curtain. But because of the way this works, we can have bi-directional traffic through the light curtain. Some of the safety considerations, you need to be able to differentiate between material and person. So you don't want a person to be able to come up and imitate the muting function that would be done by the pallet. And also, you don't want people to be able to gain access when the muting function is activated. So you can see from this picture that the light curtains are taller than the pallet. It's always possible, you could maybe view it as deliberate misuse, but somebody could maybe sit on top of the pallet or ride with the pallet into the light curtain, through the light curtain. If you deem this as foreseeable, then maybe you could look down the route of some of the advanced light curtains. The ones we offer enable you to mute just a set amount of beams. So you could leave so many at the top still live, meaning that anything outside of the pallet shape or pallet height would not make its way into the danger zone. And the other thing to consider is if you have multiple in feeds, then you may have 2, 3, 4. If you only had one set of light curtains looking all the way across all of them, then somebody could walk or travel adjacent to the pallet and alongside it and gain access to the danger zone, because as the pallet goes through one set of muting sensors, it's going to mute all of them. And so therefore you maybe need to consider actually having you would have to have a set of light curtains for every in feed or every out feed, so you don't have this situation where somebody can also, like I say, walk adjacent to the pallet and get in. There's some other considerations. Previously, the 61496 used to talk about muting time limits. This has been removed, so you can have things sitting in the muting zone for extended periods of time, because we all know that as long as you cannot get past that pallet or that product or whatever it is to get into the danger zone, then it's okay for things to sit there to process. You used to previously have to have mute indication as well. This is no longer a requirement, so you don't actually need to have a muting lamp anymore. But when you're doing an application like this, you may need to consider product recovery modes. So if something stops, for instance, or the machine breaks down, then you need to get the product back out and they're sat in the way of the light curtain and you have had a timeout, then you need to be able to automatically or manually drive these products out in a safe manner. Now on to blanking. So there's two types of blanking. We're talking fixed and floating here. We've got the pictures at the top. The top picture shows fixed blanking, and this is utilised when there's always a permanent fixture in the way of the light curtain, but you need to cover above and below this permanent fixture. So as you can see in this case, it's an outfeed conveyor, and the light curtain has beams above and below the conveyor because that's where the opening is. The beams in the middle, you are essentially creating like a window or a letterbox for maybe products and the conveyor to sit without triggering the light curtain. But what you need to do, if you're going to use this function, whatever is protruding through the protective field must always protrude through the protective field, because otherwise we could basically create a gap in the light curtain where somebody can reach through and put their hand into the dangerous area. Floating blanking. This is where you may have something that's always going to be protruding through the protective field, but where it is changes. So we've got a roll here which will slack and tighten as it turns. So you may be looking at 1, 2, 3 beams that are always going to be broken, but not the same beams. So what you can do here, again with more advanced light curtains, is as long as there are the set number of beams which have been programmed to blank, always blanked. It doesn't matter which ones in the protective field it is. It will allow the light curtain to continue to give a healthy signal. But with both of them, as I said with the first one, then beams must be permanently blanked. If they're not, then you're going to have failures of the light curtain, or it's going to trip out. And also there's the possibility for cascading of light curtains. So this allows them to be directly connected together. And the reasons why you might do this, you could use them in an L-shaped formation to give you protection against encroachment. So if you want to give a warning that somebody's coming up, or you may want to slow a machine down before somebody goes through into the danger zone, then you would have a horizontal light curtain that you would do, and you'd give the warning before you go through the vertical one. You may want to increase the area of detection. So it might not be that they're mounted end on end, that they might be cascaded in a way to look around corners, etc., or that you do want to mount them like that. So you can increase the area of detection, but still only have 2 outputs back to a controller, so or a safety relay. As we said before, in an L-shaped formation for encroachment, you could use that same formation but mounted the other way around, so the horizontal one is in the danger zone for occupancy detection. And this might be if somebody has to pass through the light curtain but stand in the danger zone to do something, and you want to detect that they've been there. Because if you've gone through a vertical light curtain and then once it's remade, it's possible to restart the machine. So you may have a horizontal one that will pick up somebody standing in this danger zone. It's always recommended that they're not above 300 mil if you're going to do this, because then you could lay underneath them, but you can use them also for occupancy detection. And this will then also prevent unexpected startup of the machine. So as we were saying, somebody can't reset them. When you are cascading light curtains, you don't want any confusion or sort of cross-contamination between the 2 light curtains, where beams may be seen by from the opposite sender by the different receiver. So you can code these, so sort of code 1, code 2. So they are looking for that specific beam sent from the sender that they are transmitted from the sender that they are paired to. So it's a nice function. So now we move on to floor scanners. So 2D floor scanners, they are a type 3 device generally, and so they'll achieve performance level D. And they can operate as a single device, just scanning the area or the field around them. Or again, they can be series connected together, often in a master-slave configuration to give to cover a wider area. They already have a wide field of view in the 2D plane. Our Pilz PSEN scan has a 275-degree area and a 5.5 meter range. So you can see they're doing big areas. As with the light curtains, they have high resolution, so they give this precise edge definition, meaning that, again, as soon as somebody walks into that protective field, that they will be detected near as damn it immediately. But they can be mounted not just horizontally, but vertically as well. So they can create like a curtain over an area, whether that's above or from the side. So they can look in the horizontal and vertical planes. When you're seriesing many together to create a larger working area, again, they can be coded as per the light curtains, so you don't have any misdetections or even undetections, which will be the worst case scenario. And the scan times you can trigger them dependent upon the number of scans. So it would generally probably most commonly be 2 scans. It picks something up the first scan, it will look back round. Is it there again? Yes, right, I'm going to trigger the light curtain, turn off the outputs. But you can increase these to 2 or 3 or 4. But what you've got to consider when you're doing this is actually you're going to increase the reaction time of the floor scanner as well. So at the minute with the PSEN scan, if I'm correct, remember right, if you have 2 scans, it's 62 millisecond scan time. If you go to 3 scans, you're 92 millisecond scan time, so on and so forth. So you're going to then have bigger safety distances. And you can see from the picture on the right, they have the functionality for warning zones and danger zones. So what that is the amber area would detect that somebody's coming towards the danger zone, and then the red zone is where you would shut the light curtain off. You have muting or dynamic muting. So again, you can allow products in or out of the area, machinery in or out of the area, and the dynamic muting would be to, dependent on what's coming in, change that configuration. So you may want to mute different parts or different sizes depending on what's coming in. These are very common in robotic applications, as you can see from the picture, and they can also be used for HRC applications, so human robot collaboration. And they sort of come into their own, particularly where you want to have a collaborative application where people can come into direct contact and expected contact with the robot, but there's very high cycle times. So if you've got a quick cycle time, then the robot needs to move fairly fast. And if the robot's moving fast, then there's a high chance you're not going to be able to achieve the force and pressure limits as in TS 15066 on the body map. So what you may do then, instead of just being a purely method 4 application, you may use a method 3, method 4 collaboration. So the robot moves full speed, does the cycle times. When somebody comes into the amber zone or the warning zone, that robot then will reduce down to the speed that you can achieve your force and pressure test measurements. And while someone's then in the red zone or the danger zone, it's moving at a speed that if they come into contact with the robot, it's not going to cause them any harm. And then as they walk away, it can come back up to speed again, come back up to full speed. So it can allow you to have collaborative applications with a method 3, method 4 solution. Floor scanners also are certified to work on moving machinery. And this is very, very common nowadays, as many of you probably know, on AGVs. So you can see the picture there. We have got the Pilz robot on the Pilz AGV. And where we talked previously about switching configurations, this is used a lot with AGVs. And they can be triggered by various things, these switches. So it could be a digital input and output, but also we have a version called the PSEN master code version of our scanner, and this would be particularly useful when, as AGVs will move at different speeds. So the faster the AGV is moving, you know, higher inertia, the stopping time is going to be greater. The faster you drive in your car, you jump on the brakes, you have a longer stopping time, don't you? So when it's moving at a higher speed, then the detection zone is going to need to be larger to pick up things further ahead to allow it to stop, to make sure it's not going to come into contact with people. And these functions can be used in conjunction with things such as ROS, with the robot operating system, or SLAM, which is the simultaneous localization and mapping. So what this does, it gives you precise locations of where the AGV is in your factory or plant. And it may be work that if you maybe have a cloud-based system which is assigning tasks to specific AGVs to go to different machines, take this product from here to there, pick that up, it's going to want to assign the task to the most local AGV. 1, saves time, 2, less distance travel, 3, more energy efficient. And when you're doing these tasks, then you're going to be it's going to be going into different cells. So you may be used in conjunction with maybe a camera-based system, where as it enters a cell, there's QR codes or similar sort of code on the cell wall. It will scan that, it will know what it is, and it will say, right, okay, now I need to be in this configuration. Now I need to be in that configuration. Or maybe now I can turn the floor scanners off because it needs to get very close to a certain part of the machine to load or unload or whatever needs to be done in that specific cell. And we spoke a second ago about energy consumption as well, because obviously AGVs are run by batteries. You don't want the scanners drawing on the battery constantly. So there's a standby mode as well. And so if it's not moving, doesn't have a task, go into standby. When it receives a command, the floor scanners will come alive again, check that everything is safe, there's nothing around the AGV before it moves, and then allow it to move on. So they can be working in very intelligent ways nowadays. Failsafe Radar is a fairly new product. Pilz have had it 2, maybe 3 years now. We're on to the 2nd generation of this product, and it has very similar functionalities to the scanners. It's also PLD Cat 3, 2nd generation. I will say it's not as precise or as configurable as a scanner. So as a scanner will look out around the range, everything has to be clear, but it has very precise. And it's in a 2D plane. Radar is volumetric, so it looks out in its arc, and it has a opening angle of anywhere between 20 and 100 degrees horizontal and a 20-degree vertical. So it doesn't look as wide, but it will look up, and these are configurable by 10-degree increments. As with others, to increase the field of view, you can series connect up to 6 of them, but whereas a scanner would contact and a light curtain would connect directly to a controller or a safety relay, the radar does need an analyzing unit. You can have up to 6 per analyzing unit. It offers the same functionality of safe shutdown and occupancy detection, and they also have quite a high, large operating range of -10 to 60 degrees. So they're very good in when we're talking earlier about environmental considerations. There's also a anti-tamper feature. So the head of the radar can be tilted dependent upon what you want to look at. Because it's volumetric as well, you may want to look down, look up, whichever way it would be. But once these are set, then there's accelerometers within the product which will pick up if they have been moved, and therefore if it does, it will deem that somebody's trying to defeat it, and then it will shut down. This is where radar really come into its own, because it can penetrate all materials except for metal and water. So you're not going to get the spurious trips that are possible from some of the other optoelectric devices. And they react to movement only. There's an adjustable sensitivity. They can be highly sensitive, so they will pick up micro movements. So it means that people, if they're standing there, I mean, we've set it up in the office a few times and tried to stand still enough that it won't pick you up. I can't do it. So it will pick up the smallest of movements. If you find you're getting some nuisance trips due to a few things, then maybe you can dial that sensitivity back a bit. But what it means there is they have the static environment can change. So it's if something's brought into the area, a pallet, there's a toolbox put down, that environment is a changing environment, then it will self-teach itself. So it has this self-teaching mode, and the static environment can change. As long as nothing moves, then it will reset and re-trigger to allow the machine to run again. They're very reliable in rugged environments, and they're resistant to dust, swarf, welding sparks, wet environments. I mean, they will even withstand up a certain amount of rain straight on the face. Bright light, you're not going to get issues with that. Like we said earlier, there's a large temperature range, but they're also resistant to vibration. So if you're in really dirty environments or really tough, harsh environments, then radar possibly is the way you would want to go. And as we said, there's a reset function. So as soon as nothing's moving in its field of view, it will automatically reset, allow the machine to run again. So it's different in a lot of its operations to the other devices, but that's where it sort of complements the range. So we've got some considerations for these sort of applications and things you want to look at. So as with any project, no matter what you're using, your first step is always to do a full and detailed risk assessment of your application. Follow the 12100 standard for risk assessments, which is the A standard. Apply your B standards and have a look again to see if there's any machine specific C standards. So as you see here, there's a robot again, so 10218 part 2. Pallet or packaging machinery 415. There's a raft of these standards. And you've got to make sure from that there's a safe solution which can be achieved without fixed guards. So it's okay wanting a scanner or light curtain or radar, but you've got to make sure that your solution is safe. One scenario where it will never be possible is if there's a possibility of ejected parts or debris from the machine. So the radar beam or some infrared beam that's given out by the other devices is never going to stop anything being ejected from the machine. So if that's the situation, then none of these products are going to be suitable for that environment. Again, when you're coming to your specification, you need to make sure, look at the environment. As we said, if it's a very harsh or dirty environment, then maybe radar's the way forward. If you need precise edge definition, you might want to look at the floor scanner or the light curtains. There's various things. It might be a case that actually within a cell, you use a combination of 2 or maybe even all 3 of these devices. And you've also got to make sure that you select the correct product from the range. This is particularly important with light curtains because there's quite a variety. So we said earlier they are classified by type in 61496. So you need to understand once you've done your risk assessment and you're producing your safety concept, what is your target performance level? Because that will dictate what the minimum requirement of the light curtain will be. So again, type 2 PLC, type 3 PLD, type 4 if you need PLE. And also the consideration around space, how close you want to be to the danger zone will dictate what the resolution of the light curtain is. So if you need to get really close, then you're going to go for finger, or as close as you can, you're going to need to go for finger. However, if you've got a long infeed and you just want to stop anybody getting on that infeed, but there's no hazard for quite a while, you may well choose to body detection light curtain. There's less beams in them, therefore they're cheaper. You know, it's all these things where they're application specific. But you've also got to consider the overall length of the light curtain as well. So you've got to look at reach over and where you mount it, how high you mount it for reach under. And there's a table in 13855 which gives you distances for reach over So it's the height of the light curtain, depending upon the height of the hazard, will tell you how far away you must be not to be able to reach the hazard behind the light curtain. So this leads us a little bit into 13855 and the safety distance calculations. So this is the general one which you would use for light curtains. It's S equals K times T plus C. So S being your safety distance, K being the kinetic approach speed for parts of the human body. So you would do your calculation using 2000 as the value for K, which is an upper arm and movement speed. And if the value comes out at greater than 500, then you would convert down to 1600, which is then a walking speed, because it's deemed that you're going to be walking into the hazard. And vice versa, if you do that and it comes out at less than 500, then you need to revert back to 2000. But so that's your kinetic approach speed. And T value, which is made up of T1 and T2, this is the part that needs to be physically measured, because you can do a calculation from the response times, etc., of your safe electric control system, but you've also got to know what the mechanical stopping time is, which is T2, and this should be measured at full load, full speed, and a worst case scenario taken. The way we would do it, if we were delivering the service for one of you guys, would be to run 10 tests of the stopping time of the machine. You trigger the light curtain, and then we have some equipment which measures the stopping time until it comes to a complete standstill, and then we do that test 10 times and use the worst case, the longest stopping time, and put that as the T value into the formula. C is the intrusion distance that the body can pass through the light curtain with before it's triggered. As we said earlier, to get closest, you would have 14mm finger detection light curtains. Nothing is able to pass through without triggering them beams. If that's the case, then your value for C would be 0. Other end of the scale, body detection light curtains, you've got to use a value of 850 for C. So you would do your calculation using that. Then you would reference as we said previously, the height of the light curtain to the height of the hazard behind, and then you would be looking at reach over, and you get a value for this. And whichever is the largest value, either CRT, which is reach through, or CRO, which is reach over, you use the highest value. So to get closest to the hazard, you would need a taller finger detection light curtain. That would give you then more floor space outside. Yes, it probably is the most expensive light curtain you would choose, but if floor space is a premium, then it's a one-off payment, and it pays for itself over the long term. Here's the calculation for laser scanners. Very similar, variation of a theme, but we have a couple of other values that we're looking at here, which is ZT and ZR. So your S, K, T, all that sort of thing is the same. T1, as I briefly mentioned earlier, the number of scans in which you're going to do depends on the stopping time or the reaction time, so it's going to increase that stopping time. And it's probably worth saying that once you've done your stop performance calculation, you've got your zone in this case. If you're getting nuisance trips and you decide to increase them number of scans, then you would have to go through that again, because it's not going to be certified to what it is. But the ZT and ZR, ZT is just a general safety allowance. Add another 150mm. That's it. ZR is something to consider when installing near intense light surfaces or reflective surfaces. So is that going to cause any spurious issues with the scanner, with its detection, with its reaction time, things like that? So something to consider there. Again, very similar calculation with radar, but we don't have the additional Z values. We have additional C values. So again, kinetic approach speed, overall response time of the radar in milliseconds, and then we've got CH and CI. So CH is an additional distance. It depends on the height of the scanning plane, essentially. But you have a minimum value of 850, which must be added, because essentially the first meter of a radar is classed as a dead zone. It will detect, but it's not certified. So for the first meter is a dead zone. And then you do 1200 by the height. You shouldn't be, again, above 300 mil from the floor, because you can deem that somebody could crawl underneath or be underneath of that. And then you use the worst case scenario. So if your calculation comes out at less than 850, you use 850. And CI is additional distance, which takes into account the sensor installation inclination. So again, there's some information there about the height. Is it greater than less than 500? But there's a minimum value of 0. So if the result of calculation is less than that, use the minimum value. And it gives you some details on there. There is a more detailed webinar on our Pilz go-to stage website. And finally, we're drawing to a close here, guys. There's a guidance document by the HSE called HSG 180. And this talks about inspections and how frequently they must be done. So it's not just a test that I break the light curtain and the machine stops. That should be just part of your general planned maintenances. This talks about actually the stop performance. So all light curtains, floor scanners, radar should have a stop performance test upon installation and commissioning at that stage to make sure that they're positioned correctly. But then they should also be periodically done throughout the life cycle of the machine or the product. And that's to ensure that this stopping time hasn't increased. It could be that there have been changes to the program or different things on the machine. It could be sped up. It could be that it's been mechanical wear if it's braked or something like that, or it's using another product, which is a new product which is heavier and increases inertia. So you've got to make sure that these stopping times are consistent and they remain the same. There's also talk in this document about how the periods between each periodic test. It says for type 4 devices, they should be carried out every 6 months, and type 2 devices every 12 months. No mention of type 3. I suppose you could surmise that it would be 9 months, but there is no guidance on that. But what is key is that they're always tested. Stop performance test is done on installation and commissioning to make sure they're in the correct position. Because if you have an accident, somebody does decide to go into the danger zone and have their colleague restart the machine to defeat it, and they have an accident, and they don't, and they say, oh no, I just walked through the light curtain and the machine didn't stop. You need to be able to prove that you've positioned them in such a way that that is not a possibility. So this would sort of back up that rationale and that design. Yes, so that's it from the webinar for today. There's a list here of some of the upcoming webinars we're delivering through the rest of the year. It's not hard and fast. Things may change around slightly, but this is what we're planning to do at the moment. So thank you, everybody. If you ask, we'll make the slides available to you, and you can view the recordings on the go-to stage along with all the rest of them. Thanks for your time. Hope you've all enjoyed it, got some out of it today. Have a great weekend. Thank you.